You'll get to see him later. He's IBM Distinguished Engineer, and he's the chief architect of our data gravity organization, which drives our cloud offerings in the data space. Now, the teams that we lead have been very busy over the last year since we last met at an IDOC conference in North America. We've delivered a lot of very innovative features in our dashDB and our DB2 on cloud offerings. And then hot off the presses is our latest release for DB2 LUW, the version 11 release, which was just announced a few weeks ago, and will become generally available next month on June 15th. So we're all looking forward to that. And no surprise, that's what we're going to talk about today. So I'll kick it off, and I'll talk about version 11, take you through the details of that release, and then I'll hand it over to Sam, and he'll talk about DB2 and dashDB offerings on the cloud. Now, folks, we think we've got leadership capabilities in our database technology in this area of analytics, cognitive computing, and cloud. And we hope that through this course of this presentation, we're going to demonstrate that to you. Now, we've got a lot of material, and we're a little bit worried about getting through it all. And I know Sam's very anxious that I get through all my material to give him enough time. So we're going to suggest that you hold off all but the most burning questions till the end of the presentation. We'll have a general Q&A session then. And of course, I'm going to be here all week. Sam's going to be here all week as well. So feel free to track us down and ask us some questions about this. So we're going to start off with version 11. There's features in this release for every workload of DB2 and every topology, whether you're using pure scale, whether you're using the database partitioning feature, or if you're just using good old single node. You'll see a lot of new features there. One of the overriding or overarching themes is breaking scalability barriers, and I hope you'll see that as I take you through this material. Now, before I get into the details, I just got to give you the obligatory safe harbor statement. Basically says we've done everything within our power to make sure the information you're about to see is accurate, but we can't give you a 100% guarantee of that. The other thing is when we talk about performance data, compression data, and numerical information like that, of course you have to realize that this is based on tests that we've done, based on specific workloads, specific environments, and of course your mileage is going to vary. So just keep all of that in mind. So here's a look at version 11. Let me just ask, I'm just curious, how many of you, before this conference, before Girish's talk this morning, have heard of DB2 LUW version 11? Great, a number of you. So hopefully you'll learn something new here. Here's a look at some of the highlights of the release. As you know, DB2 LUW is used for some of the most mission-critical workloads in the world, from running railroads and making life and death decisions there, to core banking workloads, and also runs some of the largest warehouses around the world. And you're going to see features in this release, very compelling features for all of those workloads. There's new security features, there's new availability and pure scale features, some very nice manageability and scalability improvements in the core of the data engine, which will help almost all workloads. And then on the warehousing side, as Girish highlighted this morning, we're bringing our BLU Acceleration technology to massively parallel processing. So we'll be able to use the BLU in a database partitioning environment and get that BLU Acceleration, the BLU compression, BLU simplicity at a petabyte level scale. So we're very excited about that. So we'll take you through this. We'll start off with some of the features that are more focused typically on mission-critical OLTP workloads. First of all, we'll talk about security. So I think many of you are probably aware that in 10.5 FixPack 5, we added a native data at rest encryption capability to DB2 LUW. It's very simple to use. You just create a database, and you add this new keyword, encrypt, and we'll encrypt the data for you on all of the IOs. And that's pretty much as simple as that. Very simple to use capability. It came along with a very simple way of managing your master keys through a local file system. Again, very simple. What version 11 how version 11 extends that solution is to allow it to run with centralized key managers. So if you're a very large enterprise, you've got multiple different uses of encryption in your enterprise, maybe some file system encryption, some storage controller encryption, other databases, and you'd like to use a centralized manager to manage the life cycle of your keys, DB2 with version 11 will now participate with that. We use the industry standard KMIP protocol, the Key Management Interface Protocol. So DB2 version 11 will interact with any KMIP 1.1 compliant key manager out there. IBM has one, the IBM Security Key Lifecycle Manager. There's other products from vendors such as SafeNet and Thales that support them as well. So we have that capability with version 11. Another thing that you can see there in red is a technology preview of support for so-called hardware security modules. These are actual hardware appliances that provide that centralized key management for you, whereas the centralized key manager is more of is typically a software thing that you'd run on a host. Hardware security modules are hardware appliances that provide similar functionality. We're providing a technology preview of that, and later on, if all goes well, you'll see that being productized as well on DB2. Down at the bottom of the page, I'm just giving you an example of how you might configure this, and I won't belabor the details here, but the point of this is that it's pretty simple. If you're using the local store, you'd specify the PKCS12, which indicates the standard we're using for local storage of keys. Then you specify the actual file that contains the keys. With the KMIP key manager support we have in this release, you're going to specify the KMIP protocol and then a configuration file that gives us all of the host and port information and other information we need to talk to the centralized key manager. And if you're already using the native encryption, you'll have a upgrade facility that will allow you to migrate over and from the local key store into the centralized key manager support. There's a number of other security advances in the release, and I'll just touch on these quickly. In Power 8, there's new support for hardware acceleration for encryption. Version 11 will just exploit this out of the box without any actions on your part. So if you're using this capability today on Power, you'll get a nice performance boost as you move up to version 11. We're also working on adding encrypted flows for HADR through SSL. This is probably not going to make the release in its initial GA, and that's why I put the little V11 plus there. It'll probably come in a later fix back, but it's something that we're working on. Another thing that we've done is really revamp the internal concurrency protocols that we use within DB2. Now, I'm not talking about the external protocols, that, isolations and things like that. This is a completely internal efficiency enhancement within the database. You might imagine every time an agent is accessing a page, maybe it's updating a page, and some other agent wants to read that page, there's internal latching, or sometimes known as mutex protocols that we need to use to manage that internally. We've revamped how we've done that quite significantly in this release. And the net of it is that we can get some very significant performance improvements. There's two examples here. These are both OLTP workloads, highly concurrent workloads, so really magnifying or zeroing in on this effect. And you can see that on a single node ESC workload that was running 500 concurrent connections on a transaction processing workload, we were able to demonstrate almost a 60% improvement. Now, when's the last time you had a release of any major database that improved OLTP workload by 60%? That's pretty significant. And then on the pure scale example here, again, this was a different OLTP workload, and we saw more than a double in the throughput of that workload as a result of this change alone. So we're pretty excited about this. Now, not everybody will get this sort of experience, but if you are running a highly concurrent workload where different transactions are trying to access similar pages, you should see some significant improvements. Another thing that we're pretty excited about, this is specific to power processors, is the ability to exploit the compression accelerator, which exists on Power 7 Plus and above processors, for our built-in backup compression. Now, you might be familiar with this accelerator. It's called the NX842 accelerator. It was used for the so-called active memory expansion on AIX, which allows effectively an expansion of the real memory you're able to use through compression technology on AIX operating system. We found that we can use this with our backup compression to deliver some very nice improvements in terms of the CPU costs and reduction in elapsed time for backups and restores. So let me take you through an example. This was a backup and a restore of 180 gigabyte BLU table space, so it was a columnar table. And you can see the relative size of the backup image, the backup time, the restore time, uncompressed. When we use our existing software compression for backup images, you can see, of course, that we get a nice compression, but you're also seeing that through the yellow and the pink there that the backup and the restore time is increasing significantly because of the cycles that we're consuming to do that software compression. Now, with the new exploitation in version 11 of this hardware accelerator that exists on Power 7 and Power 8, you can see that we're getting almost the same level of compression. It's not quite as good, but very close. And the backup time and the restore time is very comparable to uncompressed. So you get almost the best of both worlds here. Very nice advantage if you're on this platform. This just shows you how to exploit it or how to invoke it. You can do this on the command line, a backup command line through that incantation I'm showing you there. Or you can set a registry variable, which would result in your existing scripts, which might be specifying software compression, to now use this hardware compression. And by the way, this is also possible with log archival compression. All right? So you get some nice improvements there. Upgrades. We know upgrades is not it's almost a dirty word with some of you DBAs out there, so it's something that we'd like to focus on and make your life simpler around. And so there's three very nice improvements in this release. First one is we've added one more release to the levels of back releases we will support direct upgrade from. So I know a lot of you are still on 9.7. By the way, how many of you are still on 9.7? Can you show you? Actually, the number has gone down a little bit since the last time. If I would have asked that question last year, it would have been almost the entire room. So it's good to see. But we're going to allow those of you who are on 9.7 to upgrade to 11.1 directly. So that's a very nice improvement. The other two improvements are no longer need to take an offline backup during an upgrade, and you'll still be able to recover in the event of a catastrophic problem through a prior release online backup and roll forward. And so that's what that picture there is telling you. You're seeing an online backup that I took under 10.5 fixback 7. I was running transactions at the time. Did the upgrade. We've got some additional logging while we're doing upgrade now. Then once you're up at version 11, you open up the database for transactions. You do your first online backup. But before that backup completes, hit some sort of catastrophic problem in your storage controller, for example. Now you can go to a prior release online backup. Now, recovering is a little bit involved. And I think Melanie has a presentation which will take you through the details of how to do it. Point here is it's possible, and you don't need to take those offline backups anymore across upgrades. The other one is, if you're using HADR, I know many of you are, you'll love this one. You'll know that prior to this release, when you move up to a new level, new version, you need to take a backup on your primary restored on your standby. If you've got a 100 terabyte database, 100 terabytes of backup images are being sent over to your standby. If you got multiple standbys, this can take quite a while. So you'll be happy to know that in this release, the standby can just roll forward through that upgrade. Okay? And again, there are some more details behind how to do this. I think, Melanie, you're going to cover this as well. Both of these capabilities do require you to be at 10.5 fixback 7 or above in order to get that capability, so just be aware of that. PureScale. We'll talk, in the next few slides, talk about some PureScale capabilities. Many of you have told us that PureScale actually is pretty simple. As cluster databases go, it's pretty simple to get up and running with. But others of you have told us that it could be even simpler. And we agree. We think that you can get an exceptional availability experience, continuous availability with PureScale, online rolling version upgrades, fixback upgrades, version upgrades that are coming. Online recovery when members fail. And we would like to make that capability just available to the masses. We know that many of you or most of you are not cluster experts. You're not communication network experts. So we've really focused in this release on making this simple to get up and running. I think the complexity of the install and deployment has been reduced by somewhere between 20 and 40%, depending on what type of protocol you're using. And there's a number of other improvements in the install process. One I'm going to highlight here is if you want to set up PureScale with storage replication, it's much simpler now in this release. A lot of people love the built-in CPU redundancy that PureScale gives you. Multiple computers working on the same database. One fails, the other ones just keep going. You can also set up PureScale to have storage redundancy. It will do mirrored storage rights for you. Up until this release, that's been very difficult to do. But if you look at the steps involved now in version 11, it's much simpler. If you wanted to create a replicated file system, you used to take 8 low-level storage commands through the GPFS file system, if you know what that is. Now it takes one command. If you wanted to convert an existing file system from non-replicated to replicated, 24 commands in the past, 2 commands in this release. So much simpler to get up and running. Another thing we've done, if you're running PureScale or you'd like to run PureScale in a virtual environment, maybe you've got a set of machines and you want to have multiple different PureScale clusters across those machines. we've added the ability for those different clusters to share the same RoCE adapters, our RDMA over converged Ethernet adapters. What you're looking at here is a picture of, we've got 4 machines in this cluster, and there's 3 PureScale clusters striped across them. So you can see a primary coupling facility, a secondary coupling facility, and 2 members in this third instance. In the second instance, there's a secondary CF. Primary CF is over there on the far right, and you got 2 members. These are all separate clusters in separate LPARs, separate VMware partitions, but they can all share the same RDMA adapters. It's a very nice way of, if you wanted to consolidate multiple different workloads, many customers are doing this with PureScale. In a virtual environment, it's a very nice capability that's in this release as well. We've also extended PureScale to run on Power Linux Little Endian. And what I'm showing you here is that the scalability, the near linear scalability characteristics that we're able to achieve with PureScale are certainly delivered on that platform as well. It'll support both the high performance RDMA over Ethernet capability, as well as the vanilla Ethernet or so-called sockets capability. Both of them deliver pretty good scalability. You will get better performance, typically, especially with the more strenuous workloads with RDMA. You can see here we were able to demonstrate over this Power 8 cluster 3.5 times scaling as you scale the workload from 1 member up to 4 with RDMA, and 3.1 scalability with the just vanilla run-of-the-mill Ethernet from 1 member to 4 members. And before one more topic, a couple more topics on PureScale. We've added some more flexibility with how you can consolidate multiple different types of workloads over the same cluster through something called member subsets and a fine-grained failover priority within them. So what you're looking at here is I've subsetted my single cluster into 2 subsets, a batch subset and an OLTP cluster. You can see I've defined that through a couple of stored procedures that you see at the top of the page. I provide a database alias that is what you connect to. If you're, in this case, on the OLTP workload, there'd be another database alias for this other batch cluster that you can connect to if you wanted to run the batch workload. And you can see also that I've added a third member with failover priority 1 to the OLTP subset, and that will be used if any of the other members that are in the OLTP subset fail. So if I've got a failure on one of those members in the OLTP and the batch subset, we'll automatically fail over to those other members that we've specified with a lower failover priority. And of course, we're going to workload balance the workload across all of the members that are currently in a subset. And this can be, you can have any number of these failover priorities up to 254. You can have different subsets sharing the same member. So for example, I could set up member 2 to be failover priority 2 for OLTP. That should really be a 2 there. And that would say that if member 4 fails, then the OLTP workload is going to be spread across that member as well. And you can see that now we have batch and OLTP sharing the same member. And this is where some of the existing capabilities within DB2, the existing workload management capabilities that we have to prioritize work within a single computer, can be used to allow you to prioritize which workload, batch or OLTP, should get more cycles. We've added sync mode and near sync mode for HADR for PureScale, so now you can get that RPO 0 behavior with it. And how many of you know what GDPC is? Geographically dispersed PureScale cluster. This is a single PureScale cluster spread across 2 sites, and it gives you an active-active disaster recovery capability that's totally coherent. You know, there's no replication, there's no conflict resolution, there's no conflicts at all in this structure. We've added the ability in this release to support multiple switches on both sites within across the 2 sites. So when in the old release, when you had a single switch per site, if that one switch failed, you now would no longer have the cycles of member 1, member 3, or the primary CF. You'd still be running with the horsepower in the other site, but you'd lose all this horsepower. Now with the ability to run multiple switches on each site, you no longer have that per site single point of failure. All right, folks, we're going to change gears here now and talk about some of the very interesting warehousing improvements that we have in this release. And as Girish mentioned, this is probably the most significant capability that we have in this release. It's the ability to extend our BLU in-memory technology out to MPP and run it across a cluster. Many of you know of this technology as our DPF feature, and that's what we're talking about here. So now you can get that in-memory performance, the simplicity of BLU, the compression of BLU, at the petabyte level scale. Just like with row-based tables, we'll take a distribution key, which is a set of columns that you define. We'll hash those columns, and that tells us what partition or node each row belongs on. And then once we get that row to the node, we're going to use the columnar storage architecture to store the data. And by the way, as part of this release, we also introduced a new random distribution option. And this is useful as a simple option if there's just no appropriate distribution key for you. Any other distribution key that you might come up with just results, for example, in skewed distribution, as I'm showing in this diagram, where this node here just had way more rows than the other ones. Or if co-located joins are not really that important in your workload for whatever reason, maybe your tables are just very small, for example, this can be a very nice simple option for you. Just randomly distributes the rows across the partition. By the way, this works both with columnar and with row-based tables. And we've designed this capability to be for scale and for performance. And multiple different things that we've done, but probably one of the most significant ones is the fact that as we compress this data across all of the database partitions, within any single column, we use the same compression encoding across all of those database partitions. That's what this diagram over here is trying to show you. If, for example, if you look at the column D, they're all colored green. That's my way of showing you that they all use the same compression dictionary. They're all encoded the same way. That's important because when we send data across the partitions, we don't need to re-encode it. We don't need to uncompress it and re-encode it in the other node's dictionary. So that is really important to ensure that the solution scales. You may ask, how does it scale? And I think many of you out there would expect near linear scaling that we've been delivering with DPF for years, and that's exactly what we've been able to demonstrate this with early releases of version 11. These are two different measurements that we took. We took a 3-node cluster, and we doubled the hardware up to 6 nodes. By the way, we had 2 logical partitions on each one of the nodes, so we doubled from 6 MLNs up to 12, and we kept the data size constant. And when we did that, as you can see, we delivered almost double the volume of queries run per hour. And then the second experiment, we did very similar scale up in hardware, but at the same time, we also doubled the size of the database. In this case, it went from 10 terabytes up to 20 terabytes. And as you can see, the throughput in terms of query per hour remained almost identical. So again, you're seeing that virtual linear capability that we've been delivering with DBF for years, but now at the in-memory scale with BLU. There's been a number of core advancements in our BLU in-memory technology that apply to single node and to partitioning. These are all internal enhancements that don't require any application changes, but are going to deliver some very nice performance improvements for you. First one I'll just highlight here is the fact that we've implemented a new sort technology. Our research team at TJ Watson Research Lab has been hard at work at a brand new sorting technology, which we believe is the fastest and most scalable in the industry. You can read about it here. You'll get a copy of these slides, or you can download them, go to that PDF and read about it. We've integrated that into version 11, but even more importantly, or perhaps just as importantly, we've implemented it natively in the Columnar engine. And that means that when we run plans that contain these sorts, we don't have to convert, as we did in the past, to sort in the row engine. And I'm not going to belabor too much about this diagram on the right, but it just shows you a look at the graphical access plan before version 11 and after version 11. All of those operators that are in red are ones that were executed in the row-based engine because we needed to convert the data from columnar into row to do the sort. Now you can see in this particular query, with query 51 of TBCDS, we're running it pretty much entirely in the columnar engine. And the result, we got almost an order of magnitude performance improvement in this release. Just a few more examples, which I'm not going to cover here. Another of these core improvements is the fact that we'll now support nested loop join, again, natively in the columnar engine. This is something that we, of course, used to support in the prior releases with BLU, but again, compensated in the row-based engine. And so now when you've got access plans that depend on nested loop join, for example, a non-equality join, we're going to be able to execute those entirely in the row-based engine. Here's an example of a query I'm taking you through, and again, you can see that prior to version 11, a fair amount of this query ran in the row-based engine in red, and now in version 11, because of this native implementation of nested loop join, it's all in the Columnar engine. And this is a sort of query that you'll see a very significant improvement in. 10 times or more is pretty common with queries like this, moving up from prior to version 11 up to version 11. So there's a number of other of these sorts of internal enhancements in the BLU engine, which just provide more performance, more robustness. One of the ones I'm just going to highlight a little bit is this improved sort heap utilization. How many of you have been using BLU either in production or in development so far? How many of you have had any sort of issue with memory management? Okay, a couple of you. Certainly not a small minority of you, but a few of you. That's an area that we've improved as well. It's particularly managing sort memory across multiple concurrent uses of it and group by, hash join, that sort of thing. So you'll see some improvements there as well. Again, these are all internal improvements that are transparent to applications that should deliver pretty significant performance improvement in your workloads. And here's one example of that. This is an internal multi-user analytical workload that we have in IBM called the BD Insights workload. And when we ran this workload and compared 10.5 Fixback 5 with an early version of 11.1, we saw almost a 40% improvement across all of those queries in that workload. So again, a pretty nice improvement. So aside from the internal improvements, there's a whole bunch of external improvements in this release. New advanced SQL that are going to allow you to deliver and write more advanced analytical applications. So there's new ways of writing aggregate UDFs. We now support Netezza PL SQL. It's a new var binary data type, and there's a whole large variety of new SQL functions. With BLU, we've extended the functionality of BLU quite significantly. You can see the list here, but identity columns and generated expression columns. We've added support for code page 819, which is used quite frequently in Europe. We've added row and column access control, not logged initially support, wide row support for BLU. Logical character support is talking about the ability to deal with columns in a natural language scenario in terms of the logical count of the characters in those columns as opposed to the physical byte of the bytes in those columns. So that's a capability that we added with BLU in this release. And a whole bunch of OLAP functions have been implemented natively now in the Columnar engine, which will deliver better performance as well. A lot of these SQL enhancements that we've delivered here were under an overall theme of improving, just continuing that drumbeat of exceptional compatibility across IBM's database offerings, across Pure Data for Analytics, Netezza, and also Oracle and Postgres. So a lot of these features are going to allow you to port applications that run on those databases over to DB2 as well. And before I turn it over to Sam here, I just want to give a little bit of a plug for DSM Top. How many of you use DB2 Top? All right, look at this. That's the answer that I expect. It's very popular and simple to use interface to provide some basic and fundamental ways of managing DB2. Very popular, but it's based on some of our older monitoring interfaces, the old snapshot interfaces. So we've now enhanced it and delivered as a new tool called DSM Top. By the way, part of the reason we changed the name is because a lot of people were confusing DB2 Top with DB2 Stop and shutting down their database when they didn't mean to. So we've got a new name for it, and it is based on our new in-memory monitoring interfaces. So you should see some performance improvements with it, and it also is going to deliver some additional function around BLU, pure scale workload management, add support for Windows, add support for remote databases. There are some things that from DB2 Top which are not there yet, and we're going to continue to enhance this. And if you stumble across any of those, let us know, and that'll help us prioritize which of those we fill out in the future. So folks, I'm just going to summarize version 11, and then I'll hand it over to Sam, and he'll take you through the dashDB and the DB2 on cloud information. As you can see, hopefully here, it's a very significant new release with some very significant capabilities for all workloads and all topologies of DB2, pure scale, single node, and of course, database partitioned environments. Some very substantial performance and scalability improvements. And by the way, I'm really just touching on the tip of the iceberg here. I can't, in this short time I had, really do a decent job of giving you all the information about the release. There's a bunch of other things that I just haven't been able to talk about, and that's just a sampling. So folks, the other thing I'll mention here is that a lot of the features I spoke about have been available on the cloud for months, if not almost up to a year. So that's going to be a good transition time for me to hand it over to Sam, and he's going to take you through that in more detail.
I'm going to grab the mic.
Oh, yeah.
I'm all right. Great, thanks a lot, Matt. All right, so let's switch now to the conversation around cloud computing. Before we jump into it, let's do a quick show of hands. How many people here have some kind of a corporate directive or corporate interest in putting data repositories on the cloud right now? Quick show of hands. Wow, a huge number of you. Had we asked that question 4 years ago, probably almost nobody would have put their hand up. I want you to reflect on that. Just 4 years ago. So this, in a lot of ways, goes back to, for those of you who are in the keynote this morning with Girish, who's trying to be anonymous in the back there. But he gave the beautiful example of these inflection points in history, and in his example, he talked about exploration. There are moments in history that are pivotal points, and cloud computing is one of these inflection points. 4 years ago, almost nobody would have said they had any interest, their executives don't have interest, why would anybody want to do that? And now, most of you put your hand up, that you're exploring it. I promise you one thing. If 4 years ago it was close to 0, and now it's 75% of you, 4 years from now, it will be all of you. It's inevitable. So I want to talk a little bit about that transition in our history, in our technology history, and some of the offerings that we have available for you. Matt's done a breathtaking job at talking about the internal technology that we're using. So I'm not going to spend quite as much time on that because Matt has covered that. For those of you who want a deeper dive on some of this technology, I am doing a session on Thursday that'll go deep on dashDB. But let's talk about cloud computing as a spectrum. At one end of the spectrum, we have software that you install inside your own organization, such as DB2, Informix, yada, yada. That's where we've been in this journey for the last several decades, and it's a model that works, it's a model that's robust. The next step up from that would be, in terms of the evolution, might be an appliance, where the technology is still on premises. It's inside your four walls. But someone has gone through the effort to package it all up, so the hardware, the software is all combined, and you don't have to configure it, you don't have to tune it. It's a level of abstraction away from installing and configuring your own systems. There's an inflection point that happens next when we take technology and move it to the cloud, what we'll call a cloud image or software as a service, where that software is no longer running inside your four walls, it's in somebody else's data center. It's still yours to configure, yours to tune, yours to adjust and manage, but it's somebody else's headache to worry about getting the server up and running and making sure it's healthy on a day-to-day basis. And at the far right of the spectrum is the managed service. The managed service is the ultimate in simplicity. Not only is somebody else housing the technology for you, but they're managing it 24/7. They're configuring it, they're tuning it. You literally just use it. And that's the spectrum that exists today. And it exists today for a very important reason. It exists because not everybody is willing to go all the way for very good reasons. You may have corporate policies that say, we can't put our data in somebody else's data center. You may be concerned about the security. You may be concerned about the friction of moving the data into a remote system. You may simply have a lot of existing systems that work just great. They're phenomenal, and if it ain't broke, don't fix it. So there's a lot of reasons why every element of this spectrum is necessary today, and they're all very important to us. So our strategy in the cloud is to keep a powerful investment on that core technology in DB2 and leverage that technology in our cloud offerings as well. So Matt has spoken about DB2 on-premise. I want to speak now about things that move along the axis. So let's go, we'll start from left to right. I spoke at the highest level of simplification is the fully managed service. We have two fully managed services to offer you that are both sharing common code with DB2, and all the advancements that Matt just talked about are in these offerings. We have the dashDB warehouse, which is the MPP shared nothing scale out technology with BLU Acceleration. It uses most of the code is common with DB2, the query compiler, the connection semantics, and the BLU runtime. Much of the storage layer is common with DB2. And this is used for data warehousing. We've also just released, I think in April, dashDB for transactions. And this is a row-based instance of dashDB for which you can do OLTP processing and systems of record. Both of these are fully managed, so you don't have to worry about setting them up. You don't have to worry about managing them. Somebody else has the headache of keeping them running, so you can focus your energy on the applications and the technology that exploit them. Next level down is down in terms of letting go control, is an offering called DB2 on Cloud. And with this offering, you're still in control of the administration. If you want to adjust the configuration, various configuration parameters, you want to adjust sort heap, you want to adjust size memory pools, you want to set up HADR or even pure scale, you can do that with DB2 on the cloud. But it's sitting, the hardware is sitting in IBM data centers. Now, the next level is what we'll call private cloud or software-defined environments. In these environments, we take a step back into your four walls. In these offerings, the software is sitting and running inside your premises, inside your four walls, running on your hardware. But we've gone through great lengths to make sure that the software is very simple to use, very simple to deploy, as self-managing as possible. And then finally, we come back to the appliance story, again, sitting inside of your four walls, but moving to this common code architecture where the next generation Netezza appliance or Pure Data for Analytics is running on common code with the rest of the dashDB family. Okay, so let's jump into some of these offerings in a bit more detail. dashDB, again, fully managed using the BLU Acceleration technology, but very important in this technology evolution is getting to application consistency and compatibility with the Netezza product line. And that applies to the SQL, the PL SQL, and all of the in-database analytics, whether that's UDX, spatial analytics, statistical analytics with R, and so on. All of this running as a fully managed service in the cloud. Load and go simplicity, you don't have to configure it, you don't set it up, but just start using it. Like DB2, it has the Oracle compatibility as well, and as Matt mentioned, now has Postgres compatibility. Another thing that's very important to us is the security. If you look at all the articles on cloud computing, what you'll find is that there are two major inhibitors to adoption of cloud. The first is a security concern. Is my data going to be safe in somebody else's four walls? Second point of concern is, how the heck do I get large amounts of data over a public internet into somebody else's data center? So on the topic of security, dashDB takes an aggressive position. all of the data transfers on the wire, all the data that's sitting on disk, all the data that goes into our backups, all the data that's at rest and all the data that's in motion is encrypted all the time. That's our guarantee to you that this system is secure, and we're working very aggressively to, we have already secured a number of the industry standard security certifications, whether that's ISO, the IBM standard ITCS 104, ISO 27001, and we're just about to close on HIPAA and several others. In terms of load, we've been working with our DataWorks group to build high-performance movement of data over the internet. And on Thursday, I'll give you a deeper dive on this, but just very briefly, we're now looking at very impressive rates of data movement, very simple, where you can move data at scale. You'll be able to load 10 terabytes over a weekend. To make this really possible to use the cloud for high-volume engineering. Now, the language compatibility is incredibly important to us. And again, a couple of reasons for that. First of all, we know that customers like you are coming and you have DB2 data, DB2 applications. Some of you may also be Netezza customers. But customers are going to be bringing their data and their applications from everywhere. It's an inflection point. It's a change in how we do things. And so the data and the applications are going to be coming from an old paradigm to this new paradigm. We want them to be able to run easily. That's why this compatibility is so important to us, whether you've got a DB2 coded application or an Oracle coded application or a Postgres coded application. It's vital to us that it runs in this new Dash environment. So we have very rich support for all of these, DB2 SQL and PL SQL, Oracle, Netezza, Postgres, in database analytics with R, Scala and PySpark, Python, JDBC, ODBC, all the usual stuff. Very important to us, a tremendous focus point for us, and it's the compatibility levels now are very, very high. For DB2, it's actually basically 100% on the SQL. For Netezza and Postgres, it's now approaching 95% compatibility, and we'll close that out into the high 90s in just a few months. All right, now let's talk about, actually I think I've spoken a bit about the in-database analytics. This was a very exciting quality of the Netezza product line that became branded as Pure Data for Analytics. Built into every Netezza box is predictive analytics, geospatial analytics, and statistical analytics. All of those have been built into dashDB as well. And most of those, not quite all, but most of those into the DB2 product line on premise as well. So Matt, I think, spoke about the MPP Scale Out architecture. I'm not going to elaborate on this too much, other than to say that in addition to everything that Matt said, the common encoding across the cluster, the BLU Acceleration technology, the excellent compression, the compatibility, all that stuff is there. But there's going to be some other enhancements to elastic growth and a high availability that make this, take this to the next level of simplicity and availability and resiliency. And I'll talk about those more in a few slides. So let's say you're interested in this dashDB technology. How do you find it? Where do you go? So there's two easy launch points. First thing is you can go to bluemix.net, and inside that's our platform for cloud computing and application development. And if you go to the Bluemix catalog, as you go along the top, there's solutions, catalog, pricing, and so on. So if you click on catalog, you'll see all the services that we offer there, most of which are fully managed services. And if you scroll down to the data and analytics section, you'll see a little icon for dashDB. And then you click on that, and that's where you can get dashDB. There are several t-shirt sizes, so you can get small systems and big clusters, you know, whatever you need. But very important thing I wanted to mention is that there's a free offering. If you just want to kick the tires, try it out with a few gigabytes of data. You can do that within a few minutes, totally free. And it's great for development and test. It's great for exploring the service and seeing what it can do. Also on this same page, you'll see DB2 on cloud. And you'll see the DataWorks icon up there, which is that data movement technology that I was talking about earlier. So this is where you go for data and analytics and lots of other great services. We don't have time to go into them all. But for today, for the purposes of this conversation, this is where you can go to get Dash for warehousing, Dash for transactions, DB2 on cloud, and DataWorks are probably the most important services to keep in mind. Another great resource is our landing page for dashDB, dashdb.com. And here you can find lots of articles, how-tos, videos. It's sort of like a one-stop shop for everything you want to know about dashDB. Fantastic resource, and I recommend you go and check it out. All right. So that's the power of the science, the deep science that we put into this. And you know, it's one thing to get technology working, it's another thing to make it work that well. So we're very proud of that accomplishment. So again, as I think you can see, you know, we're proud of the technology, but we're also excited about the ability to bring it to you in a seamless and simple way. And that's really what cloud technology is all about. But I want to flip now to this topic of dashDB Local. This is a version of Dash that you can run inside of your own environment. You can run it in private clouds. You can just run it on a collection of servers that you happen to own. It's what we call a software-defined environment. And the concept of a software-defined environment is that it automatically adapts to the software that you provide it. You give it 3 small servers, fine. You give it a cluster of 20 massive honking servers, totally fine. No configuration required. You give it something small, you give it something big, it automatically senses its environment, it automatically adapts, and you're up and running. Literally, you can be up and running with a petascale system in a matter of minutes, and certainly in under half an hour, or let's say under an hour, definitely. So this gives you the ease of consumption. We've done our best to give you tremendous simplicity of management, especially because there's very little tuning and configuration required. The performance you're getting is exactly the same as that leading performance you're going to get with dashDB in the public cloud, very similar to the kind of performance you can drive with DB2 software. The big difference here is the simplification of deployment. And even when it comes to things like support, you know, let's say you have a problem with this and you need to deal with IBM and say, listen, I ran into some bug. With dashDB Local, it's literally one button push to collect all the diagnostics and have a package that goes off to IBM. So we've really gone out of our way to make it simple, simple, simple. All right. So part of the secret of this notion of a software-defined environment is this automatic adaptation to the hardware that you provide. Big servers, small servers, how do we do that? As soon as you deploy this software, the first thing that it's going to do is auto-detect your resources. It discovers the amount of RAM that's available on the server. It says, aha, here's the amount of RAM, expands into it, automatically configures memory for sort, for locking, for caching, and so on. And similarly, at the CPU level, it will auto-detect the number, the make, the model of the CPUs that are running. It will detect how many cores, how many hardware threads, and automatically adapt interquery parallelism, utility parallelism, and so on. Okay, so we're very excited about dashDB Local, and I guess before we transition, I just want to mention that it's now in open beta. It's a Docker-based deployment model. You just go to Docker Hub, and you can start downloading. You can participate in our open beta, and I really would encourage everybody to, for those of you who have warehousing needs, and you prefer to keep your data in-house, not into a public cloud, I really would encourage you to kick the tires on this, try it out. All right, let me talk about something that's coming in the future now. And as it is, you know, Matt already started with what's called safe harbor disclaimer. So the safe harbor, so I'm not allowed to say too much about timeline on this stuff, but I want to say a few words about the appliance technology that's coming in the future. And as you know, right now our hardware appliance that we sell is the Pure Data for Analytics. Phenomenal technology, absolutely phenomenal technology. And for those of you who have tried it, I'm sure you would agree. But part of the secret sauce of that technology is the very clever use of field programmable gate arrays, or FPGAs, where we encode our own very specific logic on these gate array cards that we use as accelerators inside of the appliance. So the next generation, I'm very pleased to say that the next generation of appliance that we're building will be a Dash-based appliance. It will have common code with dashDB in the cloud, but it will exploit the next generation of FPGA technology. Now, saying the words next generation technology sounds nice, but I always have the feeling that when you say, you know, something is new and improved, it's like laundry detergent. And we've all become accustomed that, you listen to these commercials, and it's like, new and improved Tide, right? Well, that was the same thing they said when I was 4 years old. So how new is it? And there's probably some lawyer out there that works for Tide Corporation going, well, as long as it's 0.001% better, you can say new and improved. So when we say next generation FPGA technology, we don't just mean that it's 0.0001% better. We're talking about something that's profound, a quantum leap in hardware acceleration. And that quantum leap is coming from these 4 little chips here. This is a photograph of the actual card that we're working on. You'll see here, this is the FPGA chip. And then you'll see over here these 4 mysterious chips. These 4 mysterious chips are hybrid memory cubes. This is a new technology, an emerging technology that's built by a consortium of companies, but Micron is the central company that actually manufactures the chip. IBM is a contributor to the consortium, and as are several other companies. And the idea of these hybrid memory cubes is that unlike regular DRAM, which is laid out in VLSI logic as a 2-dimensional array, in this hybrid memory cube, the VLSI circuits are actually layered. So they're accessed not only in 2 dimensions, but actually 3 dimensions. There's a 2-dimensional within each layer, and then there's a 3-dimensional where you point at the layer. The net effect of which is that we are no longer accessing memory that's measured in gigabytes per second. We're now able to access memory at rates that are measured in tens and hundreds of gigabytes per second. And why is that so important? Because if you want to accelerate BLU acceleration, you need to be faster than RAM, way faster than RAM. Because BLU is already running a little faster than RAM speeds. That's why we can get to speeds like 3 times faster than our competitors. We try to exceed the processing times of the latency of accessing RAM. So to make the hardware accelerator actually do some acceleration on BLU acceleration, it has to be able to access memory even that much faster. And that's where these hybrid memory cubes come in, giving us those tremendous memory times. And that's so we can feed the chip. The chip itself is able to do processing of instructions as fast as 1 cycle, 1 clock cycle. So we get to 1 clock cycle on the FPGA chip. We're able to move memory through the system at something in the range of 300 gigabytes per second, and it's a game changer for the appliance. All right, so we're very excited about that. And again, in terms of the application experience, in terms of how you code to this thing, it will be the dashDB experience, the same as you will have in the public cloud. Okay, a few other things that are very interesting and noteworthy in the Dash family. As Girish alluded to this morning, we're going to be giving you Spark access inside of the engine. I'll talk a bit more about that in a moment. Our studio comes completely integrated with dashDB. We've also integrated single button availability of Twitter data and open data. That means with a Google-like search in the dashDB console, you can search for and find whatever Twitter data you want to find and immediately load it into your database. You just imagine the potential of that to color your data, to augment your own corporate data with data that's, Twitter feeds and the activity on social networks. Similarly, we have 1-button push for open data. These are data sets that are published. They're license free by various organizations, often by governments, city hall, police departments, fire departments. They publish all kinds of information about budgets and postal codes and you name it, crime rates. And again, the potential to augment your corporate data with public data is just profound. We've added support for Jupyter notebooks and the data scientist workbench, spatial analytics, and a whole slew of built-in analytics routines for predictive analytics and deep analytics. All right, now I wanted to say a few words about elasticity and availability. These are some things that are a little different in the dashDB family from what we have in the DB2 on-premise technology. So scale out in the cloud is a very important concept. People expect the cloud to be able to grow to their needs. So the way we do this in dashDB is if, let's say, you have a 3-node cluster, servers A, B, and C, and you would like to add a brand new server. So the way we deal with this today is we essentially over-provision the partitioning of the data or the hash partitions associated with each of the servers. And all of this data is sitting either on a clustered file system like GPFS or on network attached storage, such as EBS volumes or endurance storage volumes on either AWS or SoftLayer. So now, when you add a server, instead of doing this massive redistribution command like we used to have in DB2 DPF, which usually meant an outage of many days, perhaps even a week, while you reshuffle every single record of your multi-terabyte warehouse, watch what happens this time. There's some nice animation here. I've added server number D. I'm going to take the cluster down for a couple minutes. Abracadabra. All I had to do was reassociate those slices with the new server. I didn't actually have to hash through all the records one by one. I don't know if can I go back? Let's watch that one more time. The slices are sitting. You know, I spent hours getting that to work in PowerPoint. The slices are sitting on a clustered file system or network attached volumes. I add the server. I reassociate those slices with the new server. Bada bing, bada boom. I'm up and running. Minutes, maybe 5 minutes. I'm not talking 35 minutes. 5 minutes, up and running. Now, on the clustered file system, we use an extra trick because we want these slices to be local to the server. So we actually use a technique in an extension of GPFS called GPFS FPO, which allows us in the background to move these slices so they become local to the server as well. Not only available to the server, but actually local. So in a period of hours, the data all becomes local, not only available, and it's as if you had started with 4 servers. Now, let's look at the high availability scenario. What would happen if, heaven forbid, one of these servers fails? Well, there is hardware involved, even in the cloud. It's not total magic. There's still a server running somewhere. There's a physical machine, and whenever you have a machine, you have the potential for something to break. So let's say one of these servers fails. In the case of a failure in dashDB, it is exactly the opposite of what happened when we added the server. When we added the server, we simply associated those slices to the new server. Now, if that server fails, we're going to do exactly the same trick in reverse. Watch those slices. Bada bing, bada boom. We take those slices, we associate them with the surviving servers, and we're up and running again in, let's say, 5 minutes. So it's a beautiful story. It's a complementary story, and we're excited to bring that to market. All right. I want to finish off the story of dashDB by, again, talking about another thing we're doing in the future, which is the integration of Spark. Spark is, for those, how many of you have explored Spark technology? Quick show of hands. So a modest number of you have started looking at it. It's actually the fastest growing, most active open source project in the world today. And what it really provides is, first of all, a very rich ecosystem for analytics, not just SQL. I would say SQL is actually its least interesting attribute. But perhaps most exciting is the machine learning. Actually, the machine learning is the main thing that they get a lot of noise about. The streaming technology is evolving. Graph technology is evolving. And a core set of very rich APIs to code to these things, whether it's R, SQL, Python, Scala, and Java. So the machine learning in particular is really exciting. It's really taking off in the industry as probably the most interesting aspect of Spark. The SQL is also taking off. The graph and so on is taking off. But machine learning is particularly notable. And we recognize here that there's an ecosystem that's evolving. People are going to be building applications to this. People are going to be coding to this. And we want to tap into that. But Spark has an Achilles heel, which is that while it represents a performance improvement over Hadoop of several factors, it's still slow compared to in-memory columnar processing that we would do in DB2 and in dashDB. So what we're looking at is a fusion of the best of both worlds. Let's get the richness of that ecosystem in Spark, the machine learning qualities of Spark, and fuse that with the extreme performance, the deep science that we've done in the DB2 engine to give us this fused capability that is the best of both worlds. And as for those who were in the keynote this morning, I think Gary said it very well. We want to put a little spark in every dash. We want to put a little dash in every spark and get that really power. It's like we're powering Spark with the capabilities of dashDB. Now this will give us actually improvements in two directions. It will mean that you can code applications to Spark, Spark machine learning, run them on data that's sitting in dashDB, and we'll exploit the power of dashDB, the columnar vector processing operations on encoded data, all that great stuff we've been talking about for the last few years. But it will also mean that when you want to do machine learning in dashDB, we'll be able to call out to Spark capabilities. And as that ecosystem evolves, all the richness, all the capability, you'll be able to invoke that directly from SQL issued against dashDB. Okay, so that's enough about Dash. Again, for a deeper view on this technology, join me on Thursday for a deep dive. Now let's talk now a bit more about the dashDB for transactions. This is the counterpoint to the data warehousing technology that we just talked about. You can get it from the same Bluemix landing page. Go to Bluemix, go to Catalogs, go to Data and Analytics, click on dashDB. And it's a fully managed service for transaction processing. Fully managed, so 24/7. There are people in IBM who will stand up the system, make sure that the resources are balanced appropriately for OLTP. The tables are created as row organized tables, so you can create indexes and secondary indexes on them. And you know, just like everything in the dashDB family, we ensure that the data is encrypted on the wire, at rest, and in backup images. Okay, so what does that leave for you guys to do? Well, lots. It means you can focus on the things that matter to your business, the things that are unique to your business, the schema definition, the application development, deciding who gets what access to the data, and so on. We also have DB2 on cloud. So this is where yet another offering, but gives you far more control. You can control the configuration. You can control the allocation of resources. You can configure it to use HADR or PureScale. But the advantage is the hardware and the administration of the hardware is all taken care of by IBM. Okay, so I want to just conclude with perhaps the most important thought. We've talked about some of the technology elements, but what's really going on here is more important than the technology. It's about enabling you to focus your passions on what really matters to your business, not come into work every day and focus on database knobs. We want you to come in empowered, whether you're using the fully managed offerings, software-defined environment, an appliance, or DB2 software that you install yourself. All of these things are just enablers for what really matters. You know, when I log on to Google every day, and I'm sure I log on to Google several times a day, I'm always looking for something, whether it's something for my job, something for my personal life. I am not thinking about, gee, I wonder how many servers they have behind this query. Gee, I wonder if they're storing this as relational tables or a graph or JSON. I'm not thinking about that. I'm thinking about, you know, I want to use Google to find information that's important to me. And that's what we want to do with our next generation of database technology. We want to make sure that the database technology is empowering you to get the job done as simply as possible with the most advanced capabilities, most advanced application development capabilities, statistical analytics, and so on, machine learning, and so on, so that you're not bogged down by all the knobs. And that's really what this is all about. So with that, I think we can open it up for questions.